From the JAMA Network, this is JAMA Surgery Author Interviews. Conversations with authors exploring the latest clinical research, reviews, and opinions featured in JAMA Surgery.
Hello, and welcome to JAMA Surgery Author Interviews. I am your host, Dr. Jamie Coleman. Today, we will be discussing the article, Data and the Art of the Surgical Preference Card. We are here with two of the authors, Dr. Perez and Dr. Karandeep Singh from the University of California, San Diego. Thank you for joining us on what I think every surgeon has a very strong opinion about, which is our own preference cards. And to give our listeners some perspective, I'd actually like to start by sharing two statistics and the opening sentence from your paper. Quoting, surgical costs account for 29% of healthcare spending, and operating rooms generate roughly 70% of all healthcare waste. Now that figure is truly astounding. So let's start, if you could, first by please defining, for maybe our non-surgical listeners, what surgical preference cards are, and why did you decide to look into their role in healthcare waste?
Yeah, surgical preference cards for our non-surgical inclined colleagues. I like to think of as a recipe for any surgery. It includes items, supplies, instruments, and in most cases, even positioning and medications that might be used during a specific surgical case, for example, laparoscopic appendectomy. And they're perennial, and as you've alluded to, they're the ire of many surgeons everywhere. And the reason why we started looking into this, it's been a problem at our institution since I've been there and beyond. And as residents, when we rotate through cases, there are like unlimited times where I've heard my attending or someone else say, like, it should be on my card. Why isn't that item on my card? And you get to wonder, like, what is a preference card? And really, it's a misnomer, because a preference card is actually a multi-page document that case pickers and surgical techs have to go through every day.
Yeah, so I'm not a surgeon, but I'll add to that and just say, as Sean was explaining this to me, as Chief Health AI Officer for our health system, interested in trying to use data science to try to address issues like this, basically, it's not even a recipe. It's a list of ingredients. And the list of ingredients is an overlapping set of ingredients for different recipes. So depending on if you're baking this thing or baking that thing, you might have the same ingredient list. And I think that the reason it exists that way is a real challenge. Like, it's a lot of time, effort, and work. Technologically, we often don't have the tools we need to simplify and kind of consolidate so that each case has its kind of own recipe. And then just like in cooking, every surgeon has their own set of slightly different preferences. And so that if you're trying to standardize, which is often kind of one of the core principles of quality improvement, you might standardize in ways that actually make things more expensive by putting two different sets of things on a card, one of which is actually one person's preference, the other of which is someone else's preference. So I think we address this really practical issue of starting with where we are today, not from some kind of idealistic clean slate, but based on where we are today, how would we get from where we are today to a setting where we need to be, recognizing that people do different surgeries and recognizing that preference cards exist today, and recognizing that, the actual needs might be different from surgeon to surgeon and procedure to procedure.
And actually, this is a great opportunity because I know that there's been prior work done in this area, but you all had quite an innovative methodology. Can you please explain your methodology and why you used that and decided to perform the study in that way?
Yeah, so a lot of our methodology harkens back to a previous paper by Shanker et al. Out of Stanford. It was based out of a pediatric hospital setting. And they are the ones who created this kind of linear regression model that we adapted for our purposes. They used a linear time series regression for each item used for a specific surgery to calculate what the optimal card would be. We took it a step further in knowing how our cards are used at our institution, used it in a different way. So we looked at it at 3 different levels, and really, I like to think of it as like reverse engineering, starting off with the surgical receipts to create a surgical preference card rather than in real world use, creating a preference card and just trying to guess what you're going to use for that surgery.
And so you used receipts. I think that that's really was interesting for me. So you looked at actually what was used and started from that over, again, I mean, when you started this, You had, let's see here, 1,298 preference cards in use during the study. 432 procedures were performed with 3,088 unique preference card and procedure combinations. And so then you used receipts, right? To, like you said, reverse engineer what actually was used.
Yeah, and I would say from a cooking analogy, you know that mom has a secret ingredient that they always like to use. It's not on the recipe. And I think that probably the same is kind of true in surgery. And that's why when a surgeon says, "Why isn't that on my card?" That's their secret ingredient. And so I think rather than asking people, "What do you use?" Because I think that's the way a lot of the current cards actually end up getting constructed, is through more of the, "Oh, you're using that, let me add it to your card." We said, let's start with the actual truth. What did you actually end up using? That's not necessarily a complete list because there might be supplies you need in case of emergency. And so even if you're not using them much or if at all, there might be things that you still need to have on your card just because if, XYZ complication happens, you don't have any time to wait. But in general, you can start with the receipt and I think work your way backwards. The nice thing with this kind of time series linear regression methodology that we adapted is that if an item is recently introduced on the market and people are starting to use it a lot more, it's something that we will realize is that, hey, even though it wasn't really commonly used, a few months ago, it's starting to be used more now. And so we'll project out almost like a forecast. Oh, actually, if you're making a card today and that item use has been kind of skyrocketing, that we anticipate that we actually will need to get more of that item on our card. And similarly, if there's a shortage of an item, or an item is not being used anymore because people have switched over and their preferences have changed over time, this methodology lets you account for that because ultimately, if the use of an item is declining, then we'll be able to order less of it, or in some cases actually say, based on the decline, we actually don't want to put that on the card because we see that some other item is taking the place of this item. So that's kind of, the reason for the time series is that we recognize that preferences change over time. And this method, at least in a really simplistic way, lets us account for the fact that some items are more commonly used, some are less commonly used, and that can inform the card today. So this is a one-time kind of learning cycle that we put together through a learning health system. But this is the kind of thing that we need to be equipped as health systems to do on an ongoing basis.
Now, I feel like I could just hear my surgical colleagues in my ear about this concept of streamlining or decreasing the number of items on their preference cards. What about all the potential additional time spent waiting for instruments or equipment? I mean, that clearly has implications. And did you account for that in your study?
It does, and that is one of the big risks of editing preference cards or optimizing preference cards for surgeons. You really get one shot before you burn a bridge with a surgeon. And in a lot of our manual review processes, anecdotally, surgeons always complain, "Oh, last time we did this, I didn't have so-and-so item." And so everything was added back tenfold. We looked at that as far as the cost of unused items as well as missing items for the preference cards. And through this optimization process, nearly every level of optimization, whether it was by preference cards or receipts grouped by preference cards, grouped by procedures, or by preference card procedure combinations, resulted in less missing items across the board. So I think that speaks more to how our preference cards are in a current state where they're missing a lot more items and maybe having too many unnecessary items. So I'm hoping, when we implement this and get some real world kind of prospective data, we see that surgeons are happy. Surgeons are getting what they need and limiting, the 5 minutes it takes for someone to run and find a stapler.
And what your question highlights, I think, is that every kind of thing that we do to streamline or personalize comes with a trade-off. And so I think if we wanted to just save the most money from a standpoint of having to restock, we just wouldn't have anything on a preference card because that would let you order exactly what you need as you need it. That would be a terrible experience as a surgeon, but that would be the way to get to some kind of perfect world in which there's zero need for restocking because everything is ordered a la carte. I think what we recognize is that when we're trying to, optimize, there is this risk of missing items from your card that you actually now need to order in the case. And depending on how time sensitive it is, that might be really important or really, okay, and it just takes a few minutes and you are able to kind of make up for it and doesn't actually add that much time to the overall case. All three of the strategies that we looked at actually had fewer missing items. So I think the nice thing here was that the messaging for our surgical colleagues is that not only can we take items off your list that you don't need, we can also make sure you've got the items on your list that you do need, so you have less work to do in the case in terms of ordering items.
And I think that that's the secret sauce, right? We're talking about fewer missing items and fewer redundant or wasted items. So let's talk results. After optimization, we had fewer missing items, fewer wasted items. That came with a dollar amount, correct?
It did. The dollar amount's a little bit tricky because that is the cost of, if we're saying it's an unused item, that item might get restocked and we might not actually lose that money. That item might have to get discarded and we might lose that money. That actually is a little bit harder to track. And that's why I think we focused on, as prior research has in this space, on the value of the items that went unused, assuming that like in a worst case scenario, those would need to be discarded. But there's a second component, which is the time it takes to restock. And so I think that, some of the dollar amounts are very high because those are items that went unused. If those were able to be restocked, and I think they're not all for loss, but at some point, if you bring those items out into a case and restock them, at some point you do have to go ahead and potentially discard them if they've been in and out of the case multiple times for different surgeries.
Yeah, each unused item comes with potential for loss just as a result of not being restocked, potential for accidentally being opened, which happens all the time. And then it also might increase your risk of surgical infection if items are continually moved from room to room, never being opened, but being exposed to different types of cases where you're doing a bowel case or what have you. It's all risky. And then on the back end, our peri-op staff spend hours restocking. We have pictures of entire hallways that just look like a normal inventory supply, but they're all take-back items that were unused during the day's cases.
And importantly, I think not every strategy produced cost savings. The procedure-only strategy, where we try to just take a procedure and standardize the set of items on a preference card for that procedure, that actually increased cost of unused items. And a lot of that, we think, is because, as you guys know, different surgeons have different preferences. And so if we aggregate our preferences across different surgeons, if one surgeon uses one item and another surgeon for that same purpose uses a different item, those will end up both landing on the preference card. So unsurprisingly, I think the procedure-only strategy doesn't work. And the strategies that actually worked the best were ones that took into account the fact that there is variation across surgeons. We don't want to standardize, we want to personalize.
I love that. And so for the thousands of surgeons who will be listening to this podcast, how should they go about doing this at their own hospital? Any advice on how to get buy-in from their surgical colleagues on optimizing preference cards?
That's the $1 million question. I think we're fortunate at UC San Diego to already have a lot of infrastructure around surgical receipts and preference cards, a lot of knowledge around that, which made getting this project up and off the ground much easier. As far as optimizing at other institutions, talk to your local data scientist to help you navigate the data warehouses in Epic or whatever electronic health record system you use, peri-op, stocking info you use. And then just take a look at your preference cards, really ask what's on there. When you finish a case, take a look at your back table and see what is on there that you might not even realize has been on there and they've been pulling for every case. I remember one of my attendings saying it took, as far as like turnover times, it takes him an hour just to open all the supplies. And, you look at it and a lot of that goes unused.
I think one of the really powerful things here is that because we started with surgical receipts, we showed that this work actually can be done without using up a bunch of surgeon time. I think obviously before you make a change in someone's preference card, they need to look at that change and make sure they're okay with it. And they understand what got removed, what got added, and they give the okay. But all the preparation work can almost be done ahead of time. So I think that, if surgeons are thinking about, is this something that we want to do? I think the nice thing is that they can actually get someone else to largely do the draft of all those changes and then bring it back to them. And I think the bringing it back to them is key because that's what it takes before you actually would make a change. You wouldn't want to change someone's preference card without asking. But I think the nice thing is you don't have to ask procedure by procedure for all the kind of combinations we showed of, procedures and surgeons. Do you want me to remove this? Do you want me to add that? You can kind of give them hey, based on your list, here's the actual potentially ideal recipe based on what you actually do in the case. Does this reflect what you actually want? And I think that you can maybe not get all the way to the ideal card. Maybe there's some things that they do want on there, even if they don't use them that much. But at least it gives you a way to have that conversation in a structured way that I think we don't have today.
I love that. I mean, I always say there's two currencies in life, time and money. And I think any recipe that can help give time back to surgeons is obviously a recipe for success. Thank you so much, Dr. Perez and Dr. Singh. Thank you for joining me today to discuss your article, Data and the Art of Surgical Preference Card Maintenance.
Thanks for having us.
Thank you for having us, and we want to give a special thank you to the Data Science Alliance, a nonprofit dedicated to building a thriving, sustainable, and responsible data science and AI ecosystem.
Our listeners can find a link to the article in this episode's description. To follow this and other JAMA Network podcasts, please visit us online at jamanetworkaudio.com or search for JAMA Network wherever you get your podcasts. This episode was produced by Daniel Morrow at the JAMA Network. Thanks for listening. Have a great day, y'all.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.